Let's go over what an antiderivative is and how integrals connect to derivatives. So we have the integral here of 2x dx. And we'll learn here that when we have polynomial integrals, we just do the simple power rule. And let's just say we recall the power rule from derivatives. So we have x squared, and we want to take the derivative of this. Well, the power rule just says we have x to the n plus 1, or sorry, minus 1. And then what we do is we multiply this by n. So if we apply this to x squared, we're going to get x squared, 2 minus 1, times 2. So we're just going to get 2x. And so an integral is just the antiderivative. So we're just going to do the inverse operation of this. So what is the opposite of minus? We're going to have plus. So it's going to be x to the n plus 1. And what's the inverse of multiplication is division. So we're going to divide it by n. So if we have the integral of 2x dx, all we're going to rewrite this is 2x, and this is to the first power, right? So we're going to plus 1. So then we're going to then divide it by 1 plus 1, which is 2. So then we're just going to get x squared. And then we always add a plus c when we do an integral. And if you notice, it is an antiderivative, because when we took the integral of 2x, we got x squared. But then when we take the derivative of 2x, or x squared, we're going to get 2x. And if we recall, since this is a constant here, the constants always go to 0. So it all goes, adds up. And then we can also do the same idea when we have other integrals that aren't just polynomials. So if we have the integral of e to the x, we can recall that when we take the derivative of e to the x, we just get e to the x. So then it's just the integral of e to the x is just e to the x plus c. And then it's the same thing with trig. So if we have the integral of cosine x, it's just going to equal sine x plus c. And then if we have the integral of sine x, we're going to get negative cosine x plus c. And it's the same thing where you can kind of just think about derivatives backwards when you're doing integrals. And so now let's just go over doing